We're looking at inverse trig, and I like to start with this. I'm going to start even simpler. The sine of x is equal to 1/2. Now, if I'm looking at a circle, a unit circle, when is the sine of x equal to 1/2? Turn to your neighbor, see if you can tell them when the sine of x equals 1/2. Go. All right, fire off. What are some answers that you have? Sine of x equals 1/2. Any answers? Chris? What's that? 30 degrees. So one that you might say is, I'm going to use radians, pi over what for 30? 6. Some other answers might be pi over 4, maybe pi over 3, maybe pi over 2, maybe 0. You know it's in quadrant 1, so it's going to be one of those 5. Well, what sine is? Sine is the same as what? Y. So if you were to look at the coordinate for pi over 6, it's over square root of 3 over 2, comma 1/2. You're going over this far and up this far. I like to call it the long length. It's square root of 3 over 2. The short length is 1/2 for a 30, 60, 90. And you were right. This is the y value, 1/2. Okay? But more so, what I want to impress upon you is that when students see this, what I really want you to look at is what are each of these? What is 1/2 and what is x? Well, you said that the arc length was what for this one? Pi over what? 6. So that means that this part next to sine must be an angle. Would you write this down? Or an arc length. And this is the part that's probably the most important part of understanding inverse trig, is that the number next to the sine of an angle, sine of pi over 3, sine of 30 is 1/2. Then what's 1/2? What is it? It's a point. It's a coordinate. Actually, more accurately, it's a ratio of lengths. I just call them a ratio. So this is the angle, this is the ratio. So far, so good? Now what I'm going to do, very tricky, is I'm going to write this again, but now I'm going to take the undoing sign, we call the inverse sign, the undoing sign of sine x and undoing sign of 1/2. Now when I do that, what is the undoing of the function of x? What's the inverse sign of the sine of x? Anybody guess? It's x. And this is just equal to the inverse sine of 1/2. Now, if I take this thing, x equals the inverse sine, x equals the inverse sine of 1/2, what is this right here? What is 1/2? What does it mean? It's the ratio of lengths. And what's x? Still the what? The angle or the arc length. Yeah. All right. So let's do that again. We had the sine of x equal to 1/2. And x was the angle or the arc length. Notice that's right next to sine when we have it this way. When it's inverse, the 1/2 or the ratio is next to the inverse sign. So if anything else, what I really want you to be able to see here, for some reason I lost one of my slides. That's okay. We'll go to this one. When you see any function with an x next to it, whatever it is next to the function, x must be a what? Angle. Okay? And then what is negative 1/2? Ratio. So if we're looking for the inverse cosine of 1/2, what we're doing is we're taking the ratio, and what are we looking for? We're looking for the angle. And by the way, this is way more useful. We're trying to find angles more often than we're trying to find ratios. It's easy to take the sine of an angle and get a ratio, but what we really want to do most of the time is to find the angle that gives us the ratio. Okay? I think this is the hardest part of this whole unit. If you can understand this or practice it, it's all going to make sense. Because sometimes you need to know, are we looking for an angle or are we looking for a ratio? So if I said the sine of 5 pi over 6 equals x, what am I looking for? A ratio. Okay? And if I say the inverse tangent of 4/7, what am I looking for? An angle. Super helpful if you can see the difference between that. Everything opens up and makes total sense. Okay? And I'll keep coming back to that. I think it's useful. All right. Now let's do something that's, I think, is also helpful with the notation, the cosine of 60 degrees. So here's your unit circle. Here's 60 degrees. The cosine of that is what? The x, which is 1/2, right? Oh, what if I said the cosine of pi over 3? What's that going to be? Same thing, 1/2. So again, next to the cosine is an angle, or it could be an arc length, angular arc length. But we're looking, we find that this ratio is 1/2. Now for the cosine of 60 or the cosine of pi over 3, what can you say about the ratios? They're both the same, right? So if I say the inverse cosine of 1/2, I'm taking the ratio and I'm going to find the what again? The angle or arc length. Now here's the question. Which is it? Do I want the ratio or do I want the arc length or do I want the degrees? Angles. Well, here's the way I'm going to let you answer this for me. Here's two ways to do it. Okay? The inverse cosine of 1/2, the arc cosine of 1/2. Both of these are changing the ratio, but which one do you think is turning into a radian answer? The top 1A or the bottom 1B? Which one? Yeah, this is the one. So if you see arc, you're taking the ratio and you're turning it into a radian. Okay? And if you have an inverse 1/2, what are you going to turn that into? A degree. Does that make sense? So when you see arc, you turn it into a radian, arc length. Now, some books are not consistent with that, but that's the original intent of that notation. All right, now, here's where it gets interesting. What do you think the cosine of the arc sine of 3/5 is? Blah. Huh? That sounds absolutely horrible, but let's walk through it. What is 3/5? Ratio or an angle? It's a ratio. So apparently, in this part here, we're taking the ratio and turning it into a what? And in this case, it's going to be an arc length. Yep. So we're going to just say it's going to turn into an arc length, like pi over something. But look at this. Now we're going to take the arc length, and what are we going to turn it into next? Back into a ratio. So here's a ratio turning into a arc length, turning back into a ratio. And we're going to find out what that ratio is. Okay. Does this sound like it's going to be hard? Sounds like it's really hard. Well, it is if you don't know how to sing? How many of you are in choir? Nobody's going to admit that they're in choir. Okay, but I'm going to teach you a song, and I'm going to sing it. It's actually written up on the wall. Someone's told me it's not quite correct. They're thinking of rewriting it, but this is a song I've written. It's called the Make a Triangle song. Here's how it works. If you ever see a ratio in parentheses like this, you're going to be able to sing the Make a Triangle song. And I will write on the board, Make a Triangle, but here's the song. You ready? It goes like this. Make a triangle. I can't remember the rest of it. Let me try one more time. Make a triangle. Don't remember the rest of it. Okay, so you help me out. You sing it with me. Everybody with. I know it's early in the morning, but you can do it. You ready? Garrett, are you ready? All ready? Make a triangle. Don't remember the rest. There is no rest of it, by the way. Okay? So you help me out. I know that sounded really corny, but after I do surveys for my seniors, at the end of my senior year, students remember that silly Make the Triangle song. We use it in HL2 and in further math, so you'll see this coming up. If you see an arc or an inverse inside parentheses, you can make a triangle and you can sing the song. And we'll do it a couple of times. Maybe even Ella will sing the next time. I won't make you sing it alone, though. Okay. All right, so here we go. So we have this arc. This is a ratio. Make a triangle. And this triangle has a blueprint of the sine is opposite over hypotenuse. So what will this side be? This one down here. 4, right? So 3, 4, 5, or 25 minus 9. Square root of 16 is 4, right? So that's how we would figure it out. Now we made the triangle. We turned the ratio into an angle. Now we're going to turn it back into a ratio because this tells us to do what to the triangle? Cosine it. 4/5. So the cosine of the arcsine of 3/5 is 4/5. It's not hard, as long as you can sing. And you guys have lovely singing voices, by the way. Let's zoom ahead just a bit. Go to these samples, and I think these are kind of interesting. You have the sine of the inverse cosine of 4/7, the tangent of the arc sine, and so on, the cosine of the inverse cotangent. This one will be interesting. But whenever you see an inverse in parentheses, what does that allow you to do? Ready? Make a triangle. Perfect. So very good. I did hear you that time, Ella. Thank you. Make a triangle. And so we do that. Go ahead and do that and find the sine. So if you made a triangle here, and the cosine was 4/7, 49 minus 16, I just can do that in my head. It's 33, right? So this is the square root of 33. What is the sine of theta? Because you turn this ratio into an angle. Now we're going to turn the angle back into a ratio, and what's that ratio going to be? Root of 33 over? Perfect. How many had that? Awesome. And let's see if we can do this one. Here you go again. Arc or inverse in the parentheses allows you to make a triangle. And maybe it doesn't have the arc. You can't make a triangle, only if it's an inverse, because we've got to turn it into a degree, so we make a triangle for that. Sine is -1/3, so this one's just going to be the square root of what? 8. Yep. And they might have to tell us which quadrant we're in. We'll deal with that tomorrow. This is a little tricky, but not that bad. So now I can take the tangent of this, which is opposite over adjacent. 1 over the square root of 8. And then this last one, this is the one that's a little tricky. We're still going to inverse inside parentheses. We're going to make a triangle. So we're going to do it. But wait a minute. Cotangent. What was tangent again? Opposite over adjacent, right? So what would cotangent be? Adjacent over opposite. Now you don't maybe notice it, but this is a ratio already. It's x over 1. So adjacent over opposite looks like that. I'll do that one more time. The tangent would be opposite over adjacent, x over 1. But in this case, cotangent is adjacent x over 1 opposite. And this will be the square root of x squared plus 1. So when I do the cosine of this beast, it's going to be x over what? Square root of x squared plus 1. And look at the math you're doing. Amazing. Incredible. But essentially, you're taking a ratio, turning it into a degree or radian, turning it back into a ratio. And this, all three of these are ratios. Great. And there's a couple more you can practice. One of these 4 doesn't belong. Which one doesn't belong? Can you just look at it? 11. Why 11? This one you can't make a triangle because it doesn't have inverse or arc. So all of these you would be able to figure out like what we did. All right, I think that's good. I think we got through those okay. Can you go down to, gotta find it here, day 1. And what you're doing is just changing these ratios next to arc. This is a ratio. You're going to turn them into what? What are you going to be finding? Degrees or radians. So arc means radians. So it's going to be, something pi over. So you go on your unit circle. When is the sine or the y equal to -1? What arc length is that? What's that? 3 pi over 2. Or you could say -pi over 2. Either one of those. We'll see why we wouldn't say 3 pi over 2 tomorrow, but either one of these answers are good for today. Arc sine of negative square root of 3 over 2. So, okay, negative square root of 3 over 2 is going to be down here. So that one is going to be what? I like to do it this way. The sine is negative square root of 3 over 2. So you go down here. And this is either 11 pi over 6 or 5 pi over 3. I think this one's 5 pi over 3. You could also get this one down here, which is 7 pi or 4 pi over 3. You could get both of those. So you could either have for this one 4 pi over 3 or 5 pi over 3. And we'll find out which one the calculator is going to have. There's only one of those will actually work with the calculator. We'll see about that tomorrow. But all I want you to do today is to find these. Now, for homework check tomorrow, I'm going to check your labs, and I'm going to check 2 of these, and then you should be able to do these. I'll do 1 or 2 of these. Okay? And just looking to see here. Yeah, the 214 isn't too bad. So you're going to do those. And I am assigning these, but I'm not going to check these because these are a little tricky. They're wonderful, though. these I definitely will check 2 of them. 2 of these and 2 of these for tomorrow. If you can do these, try these, and then do 214.